Hi, today's video involves indeterminate forms. And actually the next video will also. There are 7 indeterminate forms. You've seen some of them, examples of some of them previously. Let me list them. We have where my limit approaches 0 over 0, infinity over infinity, infinity minus infinity. You've seen examples of all 3 of those type. The 4th type is 0 times infinity. One piece of my function is approaching 0, the other is approaching an infinity, doesn't matter which. These are the type that we're going to deal with in this video. The other 3 I will mention now: 0 to the 0, infinity to the 0, and 1 to the infinity. These will be dealt with in the next video. Okay, and to deal with these, we have a new tool, very powerful tool, called L'Hopital's rule. I usually say L'Hopital, Monsieur L'Hopital. L'Hopital's rule says that if the limit as x approaches a of f of x divided by g of x approaches 0 over 0, then the limit as x approaches a of f of x over g of x is equal to, by L'Hopital's rule, which I'm going to write that to illustrate that we're using L'Hopital, is equal to the limit as x approaches a of f prime of x over g prime of x. Notice we do not use the quotient rule. This is one time when it's okay to do this, probably the only time when you're using L'Hopital's, and we can take the derivative and end up with the same result. This also works for the limit as x approaches a of f of x over g of x approaching an infinity over infinity form. Okay? So, for example, limit x approaches 2 of something that we did previously, something very simple, x squared minus 4 over x minus 2. Previously, we had to use algebra, x minus 2x plus 2 over x minus 2, which then reduced. This becomes just plain old x plus 2, and so my limit is 4. If I were to do this now using L'Hopital, this becomes, by L'Hopital, take the derivative, 2x over 1, and that value is 4. Simpler. Now, this is a very powerful rule. It doesn't always, it'll always give you the same, the correct result if we use it in the correct way. It only applies to the 0 over 0 and infinity over infinity forms, not the other 5 forms. We'll see what we have to do in those cases. But it isn't always the best way to go. Sometimes L'Hopital's rule doesn't help you. Most of the time it makes life easier, but there are some examples where L'Hopital's rule is not the way we want to go. I will give you an example of that coming up here. So, let's look at some examples. First one is 1b in your solved problems. The limit as x approaches 0 of x squared minus tangent of x plus e to the x minus 1 over sine of x minus the natural log of x plus 1. And as x approaches 0, this approaches 0 over 0. It's indeterminate. I will use L'Hopital. taking the derivative, 2x minus secant squared of x plus e to the x over cosine of x minus 1 over x plus 1 times 1. And notice, as x approaches 0, let's see what happens. 0 minus 1 plus 1. The numerator is still approaching 0. My denominator, 1 minus 1, is approaching 0. It is still indeterminate of that form. We will use L'Hopital again. The derivative here is 2 minus 2 secant of x tangent of x plus e to the x over derivative of cosine of x is negative of sine of x. The derivative here is plus 1 over x plus 1 quantity squared. This is x plus 1 to the negative 1. And now when I see what happens, as x goes to 0, notice my numerator is not approaching 0, so this is not going to be indeterminate, can't be indeterminate. The numerator is approaching 3. This is approaching 0. This goes to 1. The denominator, this is 0. This is approaching 1. So therefore, my end result is 3. Suppose I have, I'll leave that up there for the moment. The limit as x approaches infinity of sinh of x over e to the x. This is an infinity over infinity form. Both of these functions are approaching infinity. If I try L'Hopital, notice the word try, I get cosh of x over e to the x. This is still approaching infinity over infinity, and this is going to keep repeating over and over and over, infinitely. So L'Hopital's in this case does not help. Instead, I have to do this another way. Limit x approaches infinity. Remember what sinh was? E to the x minus e to the negative x over 2 all over e to the x. And I'm going to solve this algebraically. Let's divide numerator. Well, let me rewrite this. Make it a little simpler to see. E to the x minus e to the negative x over 2 e to the x. And now let's divide everything by e to the x. Sort of like we did previously when we had an infinity over infinity form. If I divide everything by e to the x, or multiply by 1 over e to the x if you prefer, this becomes 1 minus e to the negative 2x over 2. And now this limit is no longer indeterminate. This approaches 0, and so this limit is 1/2. Notice L'Hopital's here did not help. Let's look at the third example. I'm going to do one example of each type, so we have 2 more examples left. Suppose I have the limit as x approaches 1 from the right of 1 over x minus 1 minus 1 over the natural log of x. As x approaches 1, this denominator is approaching 0 from the positive side, and so this is approaching positive infinity. The natural log of 1 is approaching 0, again from the positive side, and so this is an infinity minus infinity form, indeterminate. For this, the first thing I need to do, I cannot apply L'Hopital's directly at this point. I have to change this algebraically. So let's do some algebra. And the basic algebra that we're going to do is get a common denominator. So ln of x minus x plus 1, right? Don't forget to change the sign there, over ln of x times x minus 1. And notice by doing this, I now get a 0 over 0 form, which we can use L'Hopital's in. And so that gives me 1 over x minus 1 over, I have to use the product rule in the denominator, first times the derivative of the second, which is 1, plus the second times the derivative of the first, which is plain old x, 1 over x. When I take this limit to see what happens, my numerator is still approaching 0. My denominator is approaching 0. It is still 0 over 0 form. Before I continue on, let's simplify this a little bit. This is regular algebra step simplification. I will multiply everything by x over x to the big fraction. I get 1 minus x over x ln of x plus x minus 1. Okay? Notice I didn't put L'Hopital here. This is an algebra step. This is still approaching 0 over 0. I like writing things are approaching so I can see what's happening. And so now I will use L'Hopital again. My derivative is negative 1 over derivative of x ln of x, again a product, first times the derivative of the second, which is 1 over x, plus the second times the derivative of the first, which is 1, plus 1, which, notice this is just 1. As x goes to 1, this is 0, and so this is no longer indeterminate, and the end result is negative 1/2. So the basic steps that I used here, I check to see if it's indeterminate in the type. If it's not in the 0 over 0 form, or infinity over infinity, I convert to 0 over 0 or infinity over infinity. Use L'Hopital. And if it still is not, still not able to determine, if it's still indeterminate, I simplify and then repeat. We do this until we can finally take the limit, figure out what the limit is. One more example to kind of illustrate this being the fourth type. The limit as x approaches 1 from the left of ln of x times the tangent of pi x over 2. And as x goes to 1, natural log goes to 0. Tangent of pi over 2 is undefined. It approaches infinity. In this case, it's actually approaching negative infinity, but that doesn't really matter. It's an infinity form. So again, I cannot apply L'Hopital's in this form. To do this, we do a little algebra trick, so to speak. If I have a times b, where a is approaching 0, b is approaching infinity, I can write this as a divided by 1 over b, and now a is still approaching 0. Since b was approaching infinity, 1 over b is approaching 0, and I've changed it into a 0 over 0 form. Or I write this as b divided by 1 over a. b is approaching infinity, and since a was approaching 0, 1 over a is now approaching infinity. And either way, I get it into a form where I can use L'Hopital. So let's apply that. I can pick. Generally speaking, if you have a choice, you do not move a natural log, especially if the other choice is to move a trig function. They are easy to move. 1 over tangent is just cotangent. And now the natural log was approaching 0. It still is approaching 0. Tangent was approaching infinity, so 1 over that is approaching 0. I can now use L'Hopital. Take the derivative. The derivative of cotangent is negative cosecant squared of what's on the inside times the derivative of the inside. Chain rule. I'm going to simplify this. This is not going to, well, let's simplify this and see what happens. But because this is kind of messy at the moment, so I'm going to simplify this algebraically first before I try and determine the limit, just because I think it's easier. And I'll just start moving stuff around. I want to write it as a single fraction. The 1 over x gives me an x in the denominator. The negative I'm going to put up top. Cosecant squared, I can deal with that, or we can leave it, we can move it as sine squared in the other side. That's easier. The pi over 2 in the denominator becomes 2 over pi when I flip it around. And so now I end up with this. And this is relatively easy to do. Take the limit. Sine of pi over 2 is 1, so squared is still 1. My numerator is negative 2. The denominator is pi. So my end result is negative 2 over pi, exactly what we thought it would be.